My dear students, now we are going to look at full subtractor. Full subtractor is a circuit which is capable of subtracting along with borrowing. So now what I try to do is I will draw the black diagram of full subtractor. So it's something like this. There will be three inputs to this full subtractor. The three inputs are A, B, then borrowing, B in. Now what we are going to get out of this? We are going to get difference, then borrow out. What exactly that we are trying to do is A minus B, A minus B minus B. Okay. So this is your full subtractor. Okay. Now what are the possibilities? If I take A can be 1 or 0, B can be 1 or 0, C can be 1 or 0. What are the possible combinations that I am going to get? It can be 1 or 0. So there are three positions. And mean to say in place of A, B, B in, I can start with the three zeros, and extreme is I can keep all ones. For this, how many possible combinations I will get is 2 power n combinations, where is n is number of positions. So what is number of positions here? 1, 2, 3. In each position I can have two values. So as n is equals to 3, 2 power 3 is 8 combinations. This is what exactly I am talking with respect to input. What about the input? Input is combination of ones and zeros. Output is also ones and zeros. Why it is? It is the fact that it is a digital circuit. Input is ones and zeros. Output is also ones and zeros. Right? Now let's look at the process of A minus B in. Okay. Let's suppose 0, 0, 0. 0 minus 0 minus 0. So likewise, I need to look at the combinations for which I'm going to do this operation, and I'm trying to look at what is the difference value, what is the borrow out value. Okay, so let's look at the inputs and outputs. Then from that we try to understand the complete circuit functionality. From that we try to derive the or design the full subtractor. Say what are the inputs I have? Inputs I have are A, okay, B, B in. What about the outputs I have? Outputs. What are the outputs that I have? D bar out. Okay. So let's write all possible combinations. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is exactly the case. Now let's look at this. 0 minus 0, 0 minus 0 is 0, 0 minus 0 is 0. So from this, difference is 0, borrow out is also 0. Now if you look at 0 minus 0 is 0, then 0 minus 1. What is 0 minus 1? 0 minus 1 we have already seen. 0 minus 1. So get a borrow. So borrow out is 1 and 2 minus 1. So what is the difference? Difference is 1. Okay. So borrow is 1, difference is 1. Similarly, what I need to do is I need to look at the other possibilities. 0 minus 1 minus 0. What is 0 minus 1? 0 minus 1 is difference is 1. Of course, right now borrow is 1 because without the borrow it's not possible. Then difference is 1. 1 minus 0. So partial value. say I am doing once again 0 minus 1, because I need a borrow from which I am going to get the difference. The difference value is 1, that 1 minus 0 is 1, so difference is 1. So now I am entering the values from this analysis. I got 0, 0, then 1, 1, then 1, 1, right? But next is, let's look at the last case, that is, I'm sorry, this case. So 0 minus 1 minus 1, what exactly it's going to give us? 0 minus 1. 0 minus 1 borrow is there. I left with 1. That 1 minus 1 is 0. So D is 0. Okay. The partial difference what I got is 1. That 1 minus 1 is 0. So this is 0. This is 1. Next, let's look at the case. What exactly the case of 1 minus 0 minus 0. 1 minus 0 is 1. Then 1 minus 0 is 0. So this implies difference is 1, but borrow is 0. So difference is 1, borrow is 0. Next, what you want? What you want is, the next case is 1 minus 0 minus 1. What is that value? 1 minus 0 is 1. 1 minus 1 is 0. So difference is 0. Borrow is also 0. So this is 0. This is 0. Next, 1 minus 1 minus 0. 1 minus 1, 0. 0 minus 0, 0. Difference is 0. Borrow out is also 0. So 0, 0. 1 minus 1 minus 1. 1 minus 1 minus 1. So what exactly that I am going to get is 1 minus 1 is 0. 0 minus 1. Whatever the cases that we got for 0 minus 1, 0 minus 1 is difference is 1 and borrow out is 1. So 1, 1. Right? So with this, what I can say is, output D0 is a function of inputs A comma B, right? So similarly, your borrow out is function of A comma B in. Three inputs are there. So what I try to do is, I write B comma B in. So similarly, B0 is also function of A comma B in, right? That's fine. Now what is D0 itself? D0 is sigma m. What are the min terms? You can write the serial numbers. Of course, you can see here. It is for this it is 1. For this it is 1. So what is the meaning of that? This is 1. This is 2. So it is 1 comma 2 comma. It is 1 for 3. Is it 1 for 3? No. It is 1 for 4. So 4, 1, 2, 4 and 7. 7 is this case. 4 is this case. This value is 4. This value is 7. Right? Or what we can do is, we can write a reference of serial numbers wherein you need not look for each and every binary value. I can write this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Okay, either way I can do it. Once this is being done, now similar way I can look for B0. What is B0 is sigma m. Okay, what is those values? It is 1, 2, 3, 1 comma 2 comma 3, and it is 1 for 7 comma 7. So what I can do now? What I can do now is, I can use the K-maps. I try to use two K-maps, okay, and I try to solve it. So let me use a 3 variable K-map here, another 3 variable K-map. One K-map is for one output, another K-map is for another output. So number of K-maps required depends on number of outputs. We have two outputs, two K-map. So this is a K-map for, let's say, D0. So we will get expression for D0. The K-map for B0. We will get expression for B0. Okay. Now I take A here, which is MSB, then B in here, B in, B in, I n. Okay, 0 1. This is 0 0 0 1 1 1 1 0. So as usual, when A is 0, so this will be 0 1 3 2 4 5 7 6. 0 1 3 2 4 5 7 6. What are the inputs? This is A, this is B, followed by B in 0 0 0 1 1 1 1 0. Right? This is 0 and this is 1. Next, what exactly I need to enter the values? For D0, 1 2 4 7. It is 1 for 1. For 2, it is 1. For 4, it is 1. For 7, it is 1. Is there any possibility of combining the ones? As there is no possibility, so they are individual. Right? So if you write this expression and if you look at it, it is nothing but A XR B XR B in. If you write the expression for D0 in full form, it will be A bar B bar B in plus this is A bar B in bar plus what exactly? A B bar B in bar plus A B B in, which is nothing but AXR BXR B in. Now let us look at B0. If you look at the B0, it is 1 for 1, it is 1 for 2, it is 1 for 3, it is 1 for 7. What I can do is I can combine these two. I can combine these two. Then I can combine these two. Let me take the different color. So I can combine these two. Okay. So with this, what exactly I try to do is I write the expression for this. I write expression for this. I'll write expression for this. Okay. So if you look at this expression, this is A bar. In this, what is there is B. So A bar B in. Now if you look at this one, wherein this is B A bar. So A bar B. If you take this one, this is B in. So your expression is A bar B in plus B in plus A bar B. This is your expression. So now what I can do is I can draw the circuit based on this. Now let's look at the circuit. So I have just inputs A, B in. I am taking A, B in. So what I am trying to do is from this, can I take a 3 input exclusive OR gate? Yes, it is possible. So this will give you your D. Okay, it's not a D0, it's just D. Okay, just D. We are using the difference D. Okay, but whereas B0. So what I need to do is I take A, I take B, I take A. From here I take A. Okay, I'll give it to the inverter. Then A bar is ready. So what I try to do is this is A bar. A bar I take B. I'll AND it. then I'll take A bar, I'll take B in. So A bar B in, then I'll take B in. So you take B, then you take B in. So one is B, this one is B in. You connect it to AND gate, then I'm going to get this three. So what I try to do is I'll club them together. I try to get OR gate, and from this I'll get my bar out. So if you look at this whole thing, this part is nothing but is your full, this is nothing but your, let's say right here, full subtractor. This is your T, this is your bar. Okay, so if you look at this, the circuit, this is your, this is your full subtractor. So we have started with X, we have started with we have started with a description, then we have ended with a circuit. So this is what exactly we have started with. We have started like this, for which we have three inputs and we have two outputs, D, B0, A, B, B in. Okay, this is exactly full subtractor, right? There was a question mark while we are discussing initially, but now what is there inside is realized. This is nothing but a design, right? So we understood the operation. We did a design for full subtractor using logic gates.